everyone. So I'm going to show you how to solve systems of equations by substitution. So here we go. If you're following along with the notes, you can copy these down. So step number 1, you're going to solve one of the equations for one of the variables. Right now the steps may not make sense till we actually look at examples. Step number 2, substitute the expression from step 1 into the other equation and solve for the other variable. So you would have already solved the equation for one of the variables, you'll get an expression, and you're going to substitute that into the second equation. Step number 3 is to substitute the value from step 2 into one of the original equations and solve. So after step 2, you will have gotten either what x is or what y is. You'll substitute it in and solve. So let's look at an example. Here we want to solve the system by substitution. So we have the equations y equals 2x minus 4 and 7x minus 2y equals 5. Equation 1 is already solved for y, so we don't have to solve for one of those variables because we already have y equals 2x minus 4. So we're going to move to step 2. We're going to substitute 2x minus 4 for y in equation 2 because we know that y is equal to 2x minus 4. So I'm going to find my y in equation 2, and I'm going to replace it with 2x minus 4. Now I only have one variable, so I can go ahead and solve it like I would solve an equation. So I'm going to distribute my negative 2, so I will have 7x minus 4x plus 8 equals 5. So that negative 2 times 2x is negative 4x, and negative 2 times negative 4 is 8. I can go ahead and combine my like terms, so I get 3x plus 8 equals 5, subtract 8 from both sides. 3x equals negative 3. Bring this up here. Divide both sides by 3. And I get that x is equal to negative 1. So now that I know that x is equal to negative 1, I'm going to substitute negative 1 for x in equation 1 and solve for y. I can do it in either equation, but equation 1 is easier to substitute it into because it's already solved for y. So I will replace x with negative 1. So this becomes y equals 2 times negative 1 is negative 2 minus 4. Y equals negative 6. So that means that the solution to the equation, or the point where they will intersect, is negative 1, negative 6. Negative 1 was my x value, and here I found that negative 6 was my y value. And I know that I can check it by substituting it back into both of my original equations. Let's look at another example. This time we're going to take a look at a word problem. You buy a total of 50 turkey burgers and veggie burgers for $90. You pay $2 per turkey burger and $1.50 per veggie burger. Write and solve a system of linear equations to find the number x of turkey burgers and the number y of veggie burgers you buy. So I need to write my system, so that means that I need two equations. Well, I know that I can take the total number of turkey burgers, I'm just going to use TB, plus the number of veggie burgers, and that's going to give me the total number of burgers that I have all together. So in the question, it tells me about the amount I have and the cost. Then to find the total cost, I can take the cost for a turkey burger times the number of turkey burgers. I can add that to the cost for a veggie burger times the number of veggie burgers. And and that will give me my total cost. So what I did here was I wrote a verbal model to help me. This is just helping me figure out how to write my system. So now I can go ahead and write my system. So I'm going to replace each of my boxes with its value. So turkey burgers is represented by X. It says X is the number of turkey burgers, plus veggie burgers is Y, and it's equal to the total number of burgers, which is 50. So there's one equation. My second equation, the cost for a turkey burger is $2. X represents how many I'm buying, plus the cost for a veggie burger is $1.50. Y represents how many I'm buying, and I know that altogether, I spent $90. So now I have my system, now I can go ahead and solve. Again, I'm going to use substitution to solve my system of equations. So step 1, solve equation 1 for x. I have a little note over here, why not solve for a variable in equation 2? Well, if we go back and look at equation 2, it's a lot more complicated and you'd have more steps to do to get one of those variables by itself. So that's why I chose to solve equation 1. Also, does it matter whether I solve for x or y? It doesn't. I just happen to decide that I want to solve for x. So in order to get x by itself, I will subtract y from both sides. So I have x equals 50 minus y. Now that I have an expression that's equivalent to x, I can substitute it into my second equation. So I'll go to my second equation and I'll replace x with this expression. So now I have 2 times 50 minus y plus 1.5 y equals 90. Now I only have one variable. I can go ahead and solve. So first I'll distribute. 2 times 50 is 100. 2 times negative y is negative 2y. Go ahead and combine my terms. I'll have 100. Negative 2y plus 1.5y will give me negative half y. I'm going to subtract 100 from both sides. So I'm left with negative half y equals 90 minus 100 is negative 10. Divide both sides by negative half. And I get that y is equal to 20. Now I'm going to take that y value and I'm going to substitute it into an original equation and solve for x. Again, I can go back and substitute it into either equation, but which one is easier to solve? If I substitute 20 here, then I have to do 20 times 1.5. If I substitute it here, I just have a little math to do to figure out what x is. So x plus y equals 50. Substitute my 20 for y. Subtract it from both sides. And I get that x is equal to 30. So what does that mean? Well, we know that x represented the number of turkey burgers you bought, y represented the number of veggie burgers. So if x is 30, that means that you buy 30 turkey burgers and you buy 20 veggie burgers. If you missed anything, remember you can go back and rewind and watch it again. Thanks.